What's up, everybody? Welcome back to Robbie's Office Hours. Today was really just kind of a vocab lesson, just ultimately getting the language down in terms of ODEs. So remember, ODEs are ordinary differential equations, and today we're talking about the order and linearity of these things. So when we talk about the order of an ODE, what do we really mean? All we mean is it's just the highest derivative occurring in that differential equation, okay? So you just scan through, you look at the equation, you say, hey, what is the highest derivative occurring? That's the order, okay? So what do ODEs look like that are called linear? Okay, these are the ones that are quote unquote nice, okay, that we actually have nice techniques to solve. Non-linear is kind of like the Wild West. We have no idea what we have some techniques, but it's kind of rough, okay, it's not as systematic. So what does an nth order linear ODE look like? It has to look something like this, okay? Where an of t is just a function of t multiplied by the nth derivative of y. This is the notation. Remember the parentheses up there from your calculus days. Y upper parenthesis n is just the nth derivative of y. Plus some other function, an minus 1 of t, y to the n minus first. So this is the n minus first derivative all the way down until we equal some function f of t. Now notice that the a's and the f's, they can be whatever you want them to be, okay? The one thing that we have to restrict, though, is that if I am saying that this is the nth order, then I do have to assume that an of t, this is not identically equal to 0, okay? Now what I don't mean is I don't mean that the function itself can be 0 at places, okay? What I mean is that an of t is not equal to the 0 number, okay? So for example, I could give you something where like an of t is equal to t squared, and that's completely fine, okay? You might argue, you're like, well, but Robbie, this is equal to 0 at t equals 0. And I'm not saying that. I'm saying an of t cannot equal the 0 function. I don't care if an of t vanishes at certain points. In this case, t is 0. That's completely legitimate. But if an of t is equal to 0, the number, then yn does not exist. It's gone. And therefore, it doesn't make sense to call it nth order. Okay, so just be aware of that. Okay, but nth order linear, they have to look something like this. All right, so what do first order linear look like? So this would be when n is equal to 1. Okay, so if n is equal to 1 and I come out to my formula, it says what? I'm only going to have a y prime, so I'm going to have an a1 of t, y prime, plus an a0 of t, y is equal to f of t. Okay, so that's what first order linear ODEs look like. All right, what about second order? Well, second order, this is when n is equal to 2. Okay, so that'll be a2 of t, y double prime, plus a1 of t, y single prime, a0 of t, y is equal to f of t. So that's what a second order linear ODE looks like. Okay, so that's the language of order and linearity. Now, when is an ODE not linear? So when is it non-linear? Okay, well, if it doesn't look like this. All right, well, that's kind of a terrible way of like describing something, right? That's kind of like describing describe the color green to me, and that's like saying, well, green is not blue. And it's like, well, facts, but like that's not super helpful, okay? In this case, ODEs are either linear or they are non-linear, okay? And so an appropriate definition for non-linear ODEs is that they're not linear, okay? They don't look like this. I know that sounds circular and that sounds terrible and all that kind of stuff, but like if there were only like two colors in the color wheel, okay, let's say they're like red and blue, whatever they are, and you say, hey, I know what red looks like. It looks like this, okay? Then to say, what does blue look like? You say, well, it doesn't look like this, right? Because there's only two options. It's just red and blue, okay? So for linear and non-linear, so we want to understand in these three examples, 1, 2, and 3, we want to say what are their orders, number 1, and are they linear or non-linear, okay? So let's look at number 1. Well, the first thing I notice is that the highest derivative occurring is 2. So I can say that the order is equal to 2. So this is a second order ODE. And now I stand back and I look at it and I say, okay, does it fit the second order ODE thing that I have here? Is there some function of t times y prime? Yes. Sine of t times y double prime. Okay, that's legit. So in this case, a2 is sine. Is there an a1 times y prime? Yes, there is. A1 is minus 1 over t squared. Okay, looking good. plus a0 is just t, okay, and f of t is 4. So is it linear? Yes, it is. So this is linear. Okay? So it's a second order linear ODE. Let's look at the second one. The second one, okay, I identify the order first, so I see the highest derivative, again, 2, so I'm going to get order 2. Order is equal to 2. And I want to know, is it linear? Well, the first thing I look at is I look at the coefficient of y double prime, and I see, okay, sine of t, oh, that's no good. That's no good, because the thing in the coefficient in front of the y double prime can only be a function of t, not y. Okay, so this thing immediately tells me this is nonlinear. Okay, so this is nonlinear. Okay, so I get that. Number 3, again, same thing. I look at the derivative. Okay, the highest derivative occurring is 1, so this is an order 1. So this is a first order ODE, so order equals 1. And I start just going down the line. Okay, is there an a1 of t times this? Yes, a1 of t is t. Yay, that wins. Okay, now I look in front of this and I say, oh, that's a problem. Because if I come up here and I look at, is there any y squareds? No, there's a y, but there's no y squareds. So this immediately tells me nonlinear. Okay, so this one is order 1 and nonlinear. Okay, so those are some simple examples illustrating this. You can jump this up to, 8th order, 10th order, 150th order, whatever you want. Just gets more complicated, but the process is the same. You're just identifying the coefficients and seeing, do they fit this particular thing or not? If they do, it is linear. If they don't, it's nonlinear, all right? Okay, so normally I just say like, subscribe, do all the stuff. I hope you do that as well. I'm going to do a call to action on this as well. If you like what we're doing here, share it with your friends, okay? Like, let's just get this known, and we'll keep it going.